Example 2 here, another example of how L'Hopital's rule is not always the best choice. If we take a look at this, we do our indeterminate form assessment, we'll see that this does give us infinity over infinity. And if we go ahead and do this limit, I'll just kind of take from there and start right here. If we use L'Hopital's rule, this would be the limit as x goes to infinity of, now the top derivative is easy, it's 1. The bottom derivative is going to be 1 over 2 times the square root of x squared plus 1, but then we have to multiply by the derivative of the inside, which is 2x. Sure, the 2's cancel, and we have that. And then here, if we flip things around, because we are dividing by a fraction, so division by a fraction is just multiplication by this fraction's reciprocal. So if we flip it, well, if we flip it, then what do we get? We get the limit as x goes to infinity of square root of x squared plus 1 all over x. And you might get the sense of what's going to happen here. Reassessing the form, we get infinity over infinity yet again. And if we do a second application now of L'Hopital's rule, we will get the limit as x goes to infinity of the derivative of the top is, well, we already did this. This is 2x over 2 root x squared plus 1 all over 1. The 2's cancel, and we get right back to our original limit. It comes right back, because a fraction divided by 1 is just the original fraction. So this is sort of an infinite loop. This is never going to quit. So that's terrible. But if we use the method of dominating terms, we can say that this limit, as x goes to infinity, would be equal to the ratio of the dominating terms, which would be x over the square root of x squared. And we know that the square root of x squared simplifies into the absolute value of x, and it's going to depend on what the sign of x is in order for us to simplify this further. Because we have x going to positive infinity, we can assume here that x is positive, and the absolute value of a positive number is just itself. So we can go ahead and say that this is equal to the limit as x goes to infinity of x over x. This cancels to 1. The limit of 1 is just 1. So dominating terms can definitely be